Okay guys, today we are looking at finding the areas of rectangles, triangles, and trapezoids. Most of this should be review for you guys. You've had this before. But a rectangle or a square, I'm going to write that in there. We have an area of length times width. For a triangle, we have our base, we have our height, which makes a right angle with the base. We multiply those together and divide by 2 or multiply by 1/2. What might be new to you is the trapezoid area. So we have a set of bases, the only parallel line set in a trapezoid. We have base 1 and base 2. We also need the height, again, makes a right angle with the base. And we add the bases together, we multiply that by the height, and then we divide it by 2. So those are our 3 basic area equations for today. So let's look at some examples. In number 1, my area equals length times width, or 9 times 4, and that gives me 36 centimeters squared for area. In number 2, I have a triangle. I'm given a height is 10 meters, and this base is 12. So my area equation is base times height divided by 2. And my base is 12. My height is 10. I divide that by 2. And I get a final answer of 60 meters squared for my final answer for area of that triangle. Number 3 is a trapezoid. So I'm going to use that trapezoid equation. So my area equals base 1 plus base 2, all of that times the height, divided by 2, or multiplied by 1/2. My parallel line set is my base. So I'm going to call this base 1, base 2, and the height is 5. So when I plug that in, I get 10 plus 7 times a height of 5, all of that divided by 2, 17 times 5 divided by 2, and I get a final answer from my calculator of 42.5 feet is the unit of measure, squared. And put a box around it so I can find it fast. Number 4 is a really strange looking quadrilateral, but it's actually a trapezoid. I have one and only one set of parallel lines. So I need base 1 for a trapezoid, base 2, and my height is the right angle. So I have enough information now to fill in my equation. Base 1 is 10, base 2 is 6, my height is 6.5, and I'm going to divide all of that by 2. So 16 times 6.5 divided by 2 equals 52 inches squared. So that's a quick review of how to do the area for rectangles, triangles, and trapezoids. Turning the page, we are looking at surface area. Okay? Now, surface area is the area of all of the faces of a 3-dimensional figure, like a cube, like a rectangular prism. Okay? So the surface area of a solid is the area of its faces or sides, or the sum of the area of every face in the solid. In example 3, I have a wooden cube. That means all of my sides are the same measure. I've got a height of 5, a depth of 5, and a, nope, that's pretty much it. So I'm going to figure out surface area. The cube has 6 faces. And face number 1 is 5 times 5. Gives me 25, in this case, centimeters squared. And I've got 6 of them. So let me write in one face. So I'm going to take 25 by 6 and get 150 centimeters squared, a unit of measure for area. And that is going to be what I get for the surface area of that cube, which is kind of like saying, what is it going to take to wrap this box in wrapping paper for a birthday present? Well, you got to have at least that much. Now, my brain doesn't do this very well. I have a hard time putting together this net and coming up with the cube, okay? If you don't have any problems manipulating that in your brain, more power to you. I wish I could do it. What I can, however, do is say I've got 1, 2, 3, 4, 5, 6 spaces. And if I know one face dimension, in this case 5 times 5, then all I have to do is multiply it by 6 and get 150 centimeters squared. At the bottom of the page, it says that you can do surface area equals 6 times the edge length squared. Well, that's the edge length times the edge length. Okay, times 6. Well, that's really what I did. But instead of memorizing this formula, I need a way to find surface area, which is going to work for everything. So this is why I prefer to work it with the faces rather than try and stick another equation in my brain, because my brain's already full. All right. So in example 4, we are to find the surface area of a rectangular prism that is 12 inches long, 8 inches wide, and 4 inches high. Okay. So this rectangular prism has a total of 6 faces, 2 faces of which are 12 times 8. That's that top and bottom. Okay. So 12 times 8. I have 2 faces, like the back and front, which are 4 by 12. So 4 times 12. And the last 2 faces, that is going to be 8 times 12. Or I'm sorry, 8 times 4. Okay? So I have all of the faces labeled out. There are 6 of them. I'm going to put these numbers into my calculator and multiply them by 2. Because this is one face, but I've got 2 of them. So I need to be able to find those individually. And I get 192 inches squared for these 2 faces. I get 96 inches squared for these 2 faces. And I get 64 inches squared for these 2 faces. I'm going to add them all together, and I am going to get 352 inches squared. Okay. So that is my total surface area for that rectangular prism. Now I can do it with the net again, okay? But guys, my brain just doesn't put this back together again. But I do know that I have 1 and 1, face 2 and 2, face 3 and 3. And if I can figure out the individual pieces, then I can just multiply them by 2, which is pretty much what I did up here. I don't need to use yet another different equation in order to solve these problems. Again, I like the one works for this. Doesn't matter whether it's a cube or a rectangular prism, it works. So turning the page again, now let's talk about volume. Okay? Volume is the amount that a three-dimensional figure will hold if it's an empty box and I pour water into it, or sand, or whatever. So a cube is a three-dimensional square, and a rectangular prism is a three-dimensional set of rectangles, believe it or not. Okay? But our volume of a cube is length times width times depth, or edge length times edge length times edge length. That shouldn't be new to you as well. Should remember that pretty easily. Our rectangular cube works the same way. I have length times what they're calling width, I call depth, and then height. So I've got the rectangle times its depth. Okay? So let's take a look at a couple of examples. Here I've got length 8, width 8, depth 8. So my area, this is an area, Miss Hart, it's volume, equals 8 times 8 times 8. And when I do that, I've already worked this in my calculator, let me just find it, I get 512 inches cubed to the third power. It is in 3 dimensions, and that depth is that third dimension that we've added to these. Right? So area was 2 dimensions, length and width, and our area was squared. We're adding depth, so our volume is cubed. In number 2, again, I have a length and a width and a depth. So my volume is going to be 11 times 6 times 5. And when I put that into my calculator, I get 330 inches cubed. Okay? Be careful with that. Your volume is cubed. Now, if you were in class, you had the opportunity to get candy for this answer of the full and complete volume of this cube. Well, my volume is 12 times 12 times 12. Length times width times depth. And my final answer for volume here is, grab a handy dandy calculator, and it is, I thought I wrote it down somewhere. Okay, I found it. That answer is 1728 feet cubed, and that is my final answer for guided practice A. The volume for guided practice B, length times width times depth. When I put all of those into my calculator, I get an answer of 4,576 feet cubed. That's supposed to be a 3. Okay? And that is the volume, surface area, and area of cubes and rectangular prisms.